Next topic is TPC and body coefficients. So why we need them? After we review the topics, you will understand we are using TPC for calculating the weight and body coefficient. Later we are going to use it for efficiency of the vessel and propeller. So what is the TPC? TPC is the stand for TPC is the stand for ton per centimeter. What that means? That means if this is our vessel and we are adding a weight to our vessel, so this was our initial water line, and as you have remembered, that distance between the water line and bottom of the vessel is draft. Okay, so if we are adding a weight, which the weight is 1 ton, definitely our vessel will be sink more. But how much will be this change of the draft? This change will be TPC, or ton per centimeter immersion. That means if we add 1 ton of the cargo to the vessel, how much draft will be changed? So that's by the definition. So by the definition, TPC is change in draft by change in displacement. Because if we are adding some cargo, the displacement will be changed, which is that by definition TPC will be change of draft over let I use another abbreviation for that one, because might you confuse them. TPC will be change in draft over change in displacement. This is the definition of TPC. But how we are going to calculate that one? So let's look at the TPC from other point of view. We are talking about TPC was change in draft by change in displacement, and if we add 1 ton of cargo, the draft will be changed by 1 centimeter. Okay, so let's cut the vessel. This is our vessel. I redraw it again. This is our vessel, and this is the water line. Let's cut the vessel from the water line. What we will have, we'll have a shape like as this one. So we talk about if we add some cargo, our vessel will be sink and the new water line will be here. So this is draft 1, and by adding some cargo, the new water line will be here. And this will be our D2 or draft 2. So if we add 1 ton of cargo and our draft has changed by this much. Okay, this part is the water, change in the water displacement. But if we look at from the side, we have a prism. Okay, so this volume, just I'm looking at that one as a 3D. The whole is the amount of the water is displaced by cargo. How much is this volume? Is, if you remember, we had mass, we have this density was mass over volume, hence mass will be density times volume. Our water, our vessel is floating in the water, and we know the displacement, we know the density. If that's the seawater, density of the seawater is 1025. If that's the fresh water, is 1. So anyhow, we know the density of the water our vessel is floated on. If we be able to calculate the volume which is changed, or volume of this prism, this could be equal to the mass we are going to add. Okay, so this prism, what we have in this one, this is changing draft. This is change in draft, and this area is, we call it water plan area, or AW. So what is AW? AW is if we cut the vessel from the water line, like as what we have done here. See, we cut the vessel from the water line. So how much is this? How is the water plan area? If we cut it, that we call it AW. So this prism is equal to, volume of this prism is equal to AW times changing the density. So we have the volume, we have the density, thus we are able to calculate the mass. How we can use this one? Let's bring its example. Let's see, if we have a vessel and we add 10 ton of cargo, we are going to add 10 ton of cargo to the vessel, and we know water plan area is, let's assume 200 cubic meter. So now you try to find how much is the displacement for that, how much will be changing the draft.